Okay, good morning, everyone. My name is Beirut Trinos. I'm the applicant for our group, and our project is called iTracker. This is Bada, and this is Jeff. So, how did we decide to come upon iTracker? So, as a clinician, I'm a family physician, and I work in the hospital. I do many physical exam maneuvers every single day, and one of them is the clinical eye exam. But inherently, it's a very subjective maneuver. At the same time, in the office or in the hospital, I use other tools such as a stethoscope and ophthalmoscope, which is a tool that we use to look in the eyes. But I also use my phone every single day because I've got a lot of applications and databases on here. So I was thinking, got a phone, have a camera on it, look in the eyes, why not potentially combine these? So we decided to develop an app that augments or helps the clinical eye exam using a mobile phone video camera to detect normal and potentially abnormal eye movements. In other words, looking at the eyes, looking at the muscles, instead of using big cameras like that or tools like that, potentially using a camera to look at the eye, to look for abnormal movements. In this case, if you look at B and I, right eye is going up, and potentially augment or replace fancy tools such as these, where there are electrodes and other cameras which look at the eyes for abnormal movements.
So basically our application was divided into 3 sections for development. Our first section was trying to detect and track the eyes. And the other one, the fourth spiral was testing and being able to detect, storing the data that we received from the eye detection into our database. And for the last step that we were working on was diagnosis, which is showing the doctor like what is wrong, what could possibly be wrong with the eyes or where they should be. And if there's anything wrong, if there's any abnormalities, actually like present them with the diagnosis, tell them what could be wrong.
So with no further ado, we'll do our demo. So before we actually show the app, I'm briefly going to show you how I do a clinical eye exam, because this is something I do every single day. So I'm going to ask Mr. Lee, my patient over here. All right. So Jeff, please look straight ahead. I want you to follow my finger without moving your head. Okay? Now, all right. Up, down. Okay. So clinically, I'm looking at his eyes and trying to keep track of all the positions by myself. So you can imagine, inherently, a different observer is going to do this and me potentially detect something or not detect something. So we wanted to potentially objectify this. So, all right. So, we developed iTracker here. All right. So, Jeff, you a little closer to me here. So, I'm going to turn the other way. All right. It shows up. As you can see, there are some detecting his eyes here. Okay. All right. So I'm going to ask.
Look left. Look right. Look up. Look down.
All right. Okay. So, unfortunately, due to some glitches with our app in terms of presenting this, although we will be able to show you the pictures. The other way, like right there. There we go. Able to look at his eyes and be able to review these at least in an objective manner. Now, because of a slight technical glitch, we have to show this on the document camera. Oh. Good.
So this is the newer version of the app. It actually extracts just the eye part and display. Yeah, and so in the result, it just extract the eye portion of the picture, and then it's easier for analysis.
Okay. Otherwise, from that point, the clinician can look into some additional details we have in the app for diagnosis. All right, so from there, we're able to all right. Look at some medical details in terms of each after each eye and if there are abnormalities. And the app would guide the user to do that. And that concludes the demo. So as an app, some of the key learning points for me, especially, we're translating some of the medical jargon in terms of how the eye is, in terms of the anatomy of the eye, what the movements are, and trying to get this into some sort of communicatable computer code that my programmers could use. Additionally, I gave them a whole list of diagnoses and things I wanted them to do, but going through this and using the spiral method, it became at least apparent to me that a lot is too much for a language that both my programmers weren't familiar with from the beginning. And additionally, doing the next step in terms of clinical validation will take a significant amount of time.
So for programmers, I guess like from the beginning, maybe setting up Android even at the beginning could have been a bit challenging. And after that, working with OpenCV it was my first time personally working with it. So I had some difficulties actually trying to understand how the algorithms would actually map to face structure, so on. I would say maybe like if we had more pair programming going on at the same time, because most of our time was spent on the engine itself to actually like detect the eyes or track them. So since like we were modifying the same file, there was like a lot of Git merges that we had to go through, which turned out to be like give us a lot of bugs. And,
yeah, and in terms of the UI, as you can probably see, we didn't really have a very polished app, and some of them because the OpenCV code is we need to tweak a lot to use that OpenCV code and to integrate with the app layout, and then also sometimes we are not very familiar with the layout itself, how to put stuff at the place where we want. And so in terms of the future work, so main thing would be make the app more polished, and then also, as you can see, the real when Beirut was testing it on me, it actually detect more directions, such as the right top, right bottom directions. So we will want to have more additional captures in more directions, and then also we want to promote this app to low-income countries or even locally to more hospitals for testing. And then eventually, if possible, we will want to install it on Google Glass and see how it works. So the doctors don't have to hold a mobile phone with him all the time.
Stick it up to the person's eye.
Yeah. Thank you.
Thank you for your time.
So, okay, just want to get an understanding of this. What can you diagnose at the end of the day?
So due to the glitch, to the slight technical glitch we had there, we're able to at least diagnose whether there is a movement, if, for example, looking all the way left, say one eye doesn't go all the way left, or like the diagram we had earlier.
Okay, so that's what I was trying to understand.
Right.
So currently you will detect it.
It will detect it, and it will say that
There's
this
insufficient motion on one of the eyes, left, right, up, down.
left, right, up, down.
Okay. That's a pretty good comment that you should keep watching. You try to remember this. You always have to start simple and move from there. You can't do too much at once. Great. Yeah.
So I'm just wondering whether it's aimed at clinicians or the regular people. And
So-
does it give you a diagnosis, the phone itself?
Absolutely. So again, the aim, at least initially, is for clinicians, simply because as it was, the clinical eye exam is somewhat subjective there. So if a user doesn't really understand what's going on, the app will give you an idea of what the diagnosis may be, but there's a disclaimer that please please review this with a clinical or medical professional.
So you showed this picture with all these electrodes around the eye.
Yeah.
How would this app be able to account for the accuracy that those devices may provide? Like,
Absolutely, good point, good point. It would certainly require enhancing our algorithms and certainly a lot more clinical testing and validation. If we tested even normal eye movements on, say, 1,000 people, we could probably get a good sense of what the normal range would be. Even though we do have, and we at least programmed into the app, the baseline ranges.
So the question was, how does your app relate to that hardware? What's the answer?
They're different. This is much lower cost, less invasive.
Great. Thank you.